What I'm doing here is trying to determine when I'm going to die.
A lot of people are working on that research. So what is all this?
My family history, factoring in longevity, propensity for disease, etc.
Interesting. Cause of death for Uncle Carl was KBB. What's KBB?
Killed by badger.
How's that?
It was Thanksgiving. Uncle Carl said, "I think there's a badger living in our chimney. Hand me that flashlight." Those were the last words he ever spoke to us.
I don't think you need to worry about death by badgers being hereditary.
Not true. The fight or flight instinct is coded genetically. Instead of fleeing, he chose to fight barehanded against a brawny member of the weasel family. Who's to say that I don't share that flawed DNA?
Well, you can always get a badger and find out.
But seriously, even if I disregard the Uncle Carl factor, at best I have 60 years left.
How long, huh?
60 only takes me to here. I need to get to here.
What's there?
The earliest estimate of the singularity, when man will be able to transfer his consciousness into machines and achieve immortality.
So you're upset about missing out on becoming some sort of freakish, self-aware robot?
By this much.
Tough break. You want eggs?
You don't get it, Leonard. I'm going to miss so much. The unified field theory, cold fusion, the dogopus.
What's a dogopus?
The hybrid dog and octopus. Man's underwater best friend.
Somebody working on that?
I was going to. I planned on giving it to myself on my 300th birthday.
Wait a minute, you hate dogs.
A dogopus can play fetch with 8 balls. No one can hate that.
Bayes' theorem. Is there love or hate? No one is indifferent. Before that, there was a small excerpt from the popular sitcom The Big Bang Theory, where the main character calculated how long he had to live with the help of Bayesian theory. Hope that it was very interesting. I don't know. So, hello everyone, and today I want to introduce you to one simple for some and very difficult for others topic, like Bayesian theorem, which follows from conditional probability. And you're saying, oh, probability, again, dice, cubes, cards, balls, and so on. But no, because in this video we will consider the theorem in real life, since Bayesian theory can be applied for absolutely every area of our whole life. First, a little history about the origin of this theorem. This theorem has a rather impressive 200-year history. Thomas Bayes, whose name was given to the world-famous theory, was born in 1702 in the family of a priest. Since childhood, he was fond of mathematics, logic, and probability. He was completely absorbed in finding the approximate probability of some future event about which he knew nothing, except for the past of this event, that is, the number of times when this event occurred, or maybe not. In the 1740s, he came with the decision that original opinion plus new proof gives us new judgment. Despite his brilliant mind, he never published a single work in his entire life. This was done by his friend, Richard Price, when after the death of Thomas, he found his notes and saw in them brilliant logic and broad meaning. Now let's move on to the theoretical part. What is a Bayes' theorem? The original definition sounds like this. Bayes' theorem is one of the main theorems of elementary probability theory, which allows you to determine the probability of an event provided that another statistically interdependent event has occurred. In other words, using the Bayes formula, you can more accurately recalculate the probability, taking into account both previously known information and data from new observations. Did you get it? Think about where the Bayes theorem can occur in real life. The answer is everywhere. Yes, almost everywhere. In modern times, this theorem is widely used in search and rescue, spam filters, and so on, and a lot of other topics. Let's take a look at the topic of spam filters, as this is closer to ourselves because almost everyone has an email. Am I right? Bayesian filters are now more popular than regular email filters because they tend to be adaptive to each user. So how do they define spam? These filters have like a pre-list of potential words which usually contain spam message. This list is constantly changing under the influence of each new letter received and user actions. For example, you have registered in the online store. Let's take an example of FlipKZ, and you always receive emails with notifications about promotions, new products, or discounts. Then the Bayesian filter will perceive the words of the letter with the name of this online store. In our case, it will be FlipKZ, with low probability of spam. But if you will receive an email from another store, let's take an example like Wild Berries, then this letter will end up to spam since you're not interested in this. So in our case, our formula looks like this, but we don't focus on it right now because we will focus on our formulas in the next video. Bye!